G'day everybody. Well, it's time for another video on the hammer mill. I know it's been a while since the last one, and I've made a few modifications to it since then. First one being the top, which as you remember was extremely noisy when it was running up. And I've basically put a strip of Raven draft excluder, some of this stuff on the top here. It's what I used to go around the whole front edge of this to help seal it. But that has made a major improvement in the noise that you virtually cannot hear it at all now. So if you are going to build your own hammer mill, just make sure you get some of this stuff and put it on. It works a treat, it's dirt cheap as well, and it makes a major difference in the noise of your machine. I've also added a little flap here as well, which also acts as a platform to sit your objects on, so you can just flick it down like that, and it also stops things from shooting back out at you when you lift the lid on it. Looking inside, I've added a much coarser screen. We've got 20mm slots now, bar slots, which just allow for just the crude separation of metals, and it also just allows things to fall out and stop stuff from bouncing around on the inside. I've also reinforced the hammers as well. I've added case hardened steel tips to it, which basically I welded them on while they were still red hot, dip them in oil, and that will harden them, so that way they'll get a bit more life out of the hammers before I've got to cut them off and replace them. And yeah, put wheels on the stand, reinforced all that as well, so you can now move it around quite easily. And got the nice collection bin in place. I want to make up a bit of a frame for that as well to sit it on, but for now it just does alright like that. And so yeah, it's ready to rock and roll pretty much. Got a whole variety of materials we're going to test out on it today. Got beer tops, couple of thermal overloads from refrigerant compressors. We throw out a lot of these at work. They're off of these compressors. They just stop them burning out. And they do have silver in them, so if I can liberate silver somehow, then that'll be interesting. Got electric motor armatures. These ones I've actually removed the shafts from, but we've also got some with shafts on, so we'll just throw those in, see what happens. Got lamp bases as well, which we're also going to try out, see if we can actually separate the glass and the other crap from it and get left with clean brass. And then we've got transformers, known in the scrap world as copper bearing motors, but the little ferrite ones, so we should be able to break them up and liberate all the copper and stuff out of it all. And we've got a little test sample already ran for, and it actually works really well. Motors, it sort of turns them into a meatball, but I'm sure I could feed them through a couple of times and bust them up. Then if I feel brave enough, I might put some whole electric motors through and see if it can knock those apart. So let's get to it, see what we can start feeding to it. Always wear a set of these when you do play around with machines like this, as you get all sorts of particles flying out at different angles. Can be quite dangerous at times. Just putting these through mainly to knock the slag off the welds. Sometimes they do just fall straight through. Might be a bit big for it. We'll see how it goes. And the entire rotor's got copper wound all the way around it. It's going to be fun cleaning this thing. It's a big one. It's all your ferrite and other stuff. That one could probably do with going through again. Broken them up really nicely though. Very pleased with how that's all come out. Get it in focus. One's gone missing. Oh no, there it is. You do need to put them through a couple of times to start to loosen the copper up. They do work. It does work pretty well. There's a couple with shafts on, just to just went straight through it. And knock the shaft off of that one. There's that one there. Try him again. That sounded a bit better. Certainly beats them around a bit. There's even a bit of clean copper there. That's what we're looking for. That's what we're looking for. Some of that copper from before. There's our silver right there on the ends of these. Big one. Probably a bit too big for this. Turn it off. Isolated, so we're safe. Alrighty, here's the end results from our shreds. What we're looking at here is the motor overloads. You can see it's done a real nice job of breaking up the plastic casings and liberating all the silver contacts and the brass and the other stuff. There's a little brass calibration needle. There's another one there. It's a little spring type thing. You see these little things on the end here are actually silver. So it's done a real good job at breaking all those up. So we've got clean metal out. And these are the SAS tops that I put in. I just put them in to knock off some of the slag. Not that it mattered, but just from where I've been welding, because I use an arc welder. did alright on most of them. I mean, there was that one there, as you saw, just did not want to break up, but beat them up alright. Hopefully a lot of the other rubbish came out with it. It's a little bit of clean copper I just managed to pick out. It does a real nice job of knocking apart the old ferrite transformers, which you can see here. See, there's a few cores there. That one's somewhat clean. Lots of copper. Get a little bit of tape and plastic in there, but it doesn't matter too much. There's one that didn't quite break up. The rest that's all ferrite and plastic and just the rubbish pretty much. Here's our motor armatures here, which is pretty much turned into copper meatballs now. I'd have to process these a fair few times to be able to get the copper out of them, but it's just all the other rubbish, bits of commutators and stuff, and the plastic that's been knocked out of them. That one, amazingly, the whole shaft just fell out. In fact, both of them. So it certainly did alright at that. There's a few more there. That one almost made it. And a little motor there I'll put through it. Let's knock the end off and the armature's ready to come out. Another one. Here's our light globe bases. This is the one that actually worked best on, I reckon. This is the best result I've had out of everything. Got glass and the glue, or whatever it is they put in the caps to glue them onto the bottom of the bulb. You can see it there. That's a complete one, E27. And it's done a real nice job at knocking out all the rubbish, all the brass and stuff's now all clean. It's nickel plated, so it's not worth a whole lot for scrap, but it's definitely a lot better than it was. That's an E27 base there. That's that big one. Certainly made a noise when it went through. But, it's pretty good. Also, for those who do like scrapping things and like just seeing the usual old reckless destruction of things in hammer mills, check out Mount Baker Mining and Metals on YouTube. I'll put a link to their channel, but they do some fascinating videos on the hammer mills that they actually build for mining and scrap metal and all sorts of other things. And that's actually a channel I got a lot of inspiration off of for when I built mine. So check them out if you haven't already, and give them the sub. They do some really nice mills. I've also found out where all that copper went that was making all that noise. It's just unwound it from the transformers and motors and just rewound itself onto the rotor, so I'll have to cut all that out. But that's the mill. Camera's not in focus, I know, I apologise, but I hope you enjoyed that, bit of fun, and thanks for watching. Got some pretty good results out of all that.